All right, today we're going to do everything we've been doing. Ryan. We're going to be doing everything we've been doing, except we're going to do it without a graph. So we've been doing all of our function analysis using the graph of what? F prime. Okay, today we're going to do all the same stuff, except we're going to do it without a graph. Okay, that's what we're looking at doing today. All right, so here's my function. I got f of x equals 4x cubed minus x to the 4th. So tell me some of the things that we found when we were looking at the graph of the derivative. Raise your hand for me. Tell me something, Nancy. Critical points. All right. How did we find critical points, Nancy? Say it again.
Zeros of the function.
Zeros of what function?
F prime.
F prime. What else? What else can produce a critical point from F prime besides a zero? Yeah, if F prime is undefined. So if F prime is 0 or undefined, then that means I've got a critical point. Okay, what are some other, somebody else raise your hand? Ethan?
Points of inflection.
Points of inflection, how do I find points of inflection?
Anytime the derivative goes from increasing to decreasing.
Okay, and what word do I want to use instead of goes?
Changes.
Changes. So anytime my derivative changes from increasing to decreasing or vice versa. All right, so critical points, points of inflection, what else have we found using the derivative? Deborah?
Relative extrema.
And how do I find that? What's going on?
It's whenever the derivative changes from a positive or negative or vice versa.
Okay, so from positive to negative or negative to positive, I get a relative extrema. Very good. What else? Somebody else raise your hand. We've got at least two more things. Tell me.
Intervals of concavity.
Intervals of concavity. How do I find intervals of concavity?
Find where it changes from positive to negative. Well, increasing to decreasing.
That's points of inflection.
What's
So how do I know when something's concave up or concave down?
it's decreasing?
What's decreasing?
The interval?
What's decreasing though?
Oh, F prime.
F prime is decreasing. That means F is what?
Concave down.
Concave down. And if F prime is increasing, that means F is
Concave up.
concave up. All right, there's one more thing that we haven't talked about yet. Alexis?
We've been able to tell if F prime is increasing or decreasing by, not F prime, by F being increasing or decreasing by F prime being positive.
Perfect. There it is. That's the last one. So I know F is increasing if F prime is positive. I know F is decreasing if F prime is negative. Okay? So we can do all of that from the graph of the derivative. We want to do all that same stuff starting with F, okay, and without a graph. Okay? So what do you think we need to do?
Find F prime.
We need to find F prime. Good, Ethan. Go ahead and find F prime while I answer the door. Thank you. All right, what did we get for F prime?
All F squared.
Minus 4x.
All right. Now what? What's pretty much the most important thing we want to find from F prime? Alexis?
I was going to say we just solve for 0.
All right, what are we finding if we do that? We're finding critical points. Critical points are the first thing we want to find. Okay, so as Alexis said, we want to set this equal to 0. Okay, because what can happen at critical points?
Relative extrema.
We can have relative extrema. So critical points are pretty important because relative extrema might happen there. All right, so how am I going to finish this problem right here? How am I going to solve this? Factor out 4x squared. So that gives me 3 minus x. So what two x values do I get? I get 0 and 3. So what are 0 and 3? Critical points. So what might be going on there? Relative extrema. And the other day, I know Ethan caught on to it. if a critical point is not a relative extrema, more than likely, raise your hand, it's going to be, Gavin? Nope.
Point of inflection.
Point of inflection. Okay. All right. Now, how do I tell if these things are relative extrema? What has to happen at a critical point in order for it to be a relative extrema? Changes from positive to negative or negative to positive. So what can I do to figure that out?
Put in a number just before 0 and just after 0.
All right. So I want to draw something. I want to draw a sine line. And I'm going to put 0 and 3 on there. Okay, and then I'm going to plug in a number in each section, figure out whether or not it's positive or negative, and then I can know whether or not it's changing and whether or not it's a max or a min. Okay? All right, what's a good number to the left of 0? Negative 1. Now, regardless of what I plug into this first piece is always going to be positive, so I can ignore that. So really, all I have to do is plug into that second piece. So if I plug negative 1 into that second piece, is it producing a positive or negative number? It produces a positive number. Okay, number between 0 and 3? 1. If I plug 1 in there, produce a positive or negative number? It produces a positive number. Number over here? 4. If I plug 4 in, that produces a negative number. Now, notice when I'm plugging in, what did I not find? The exact value. Good job, Nancy. Do not waste your time finding the exact value. I don't need to know the exact value. All I need to know is what?
It's positive.
If it's positive or negative. So don't waste your time. Okay? You've got to be time efficient on this test. All right. So, do I have any relative extrema? Where? 3. What is it?
It's maximum.
So I have a relative max at x equals 3 because you said a cuss word.
F prime changes from positive.
F prime changes from positive to negative. Perfect. All right. Now, what's something else I could find by what's something else I could state by looking at this sine line right here? What else do I know?
1 is a point of
1's probably going to be a point of inflection. We'll get to that later, though. It was the last thing. It was the last thing that Alexis said. Alexis, what did you say?
When F is increasing or decreasing.
When F is increasing or decreasing. So when is F increasing? When F prime is positive. So what's my interval? Negative infinity to 3. And my justification would be because
F prime is positive.
F prime is positive, and I'm decreasing from
3 to positive.
3 to positive infinity because F prime is
Negative.
negative. So negative infinity to 3, I'm increasing, and 3 to infinity, I'm decreasing. All right, so I've got the graph of this thing on the next page, so we're going to verify everything we just wrote down is happening on this page. All right, so we have a relative max at x equals 3. Is that true on this? Notice that each line is worth how much? Each mark is worth how much? If I'm 10 here, 2. So do I have a max at 3?
Yes.
Yes. Am I increasing from negative infinity to 3?
Yes.
Yes. Am I decreasing from 3 to infinity? Yes. Okay, so everything we've done so far, we just verified on our derivative graph. Or that's the actual graph, sorry. All right, so what else can we find? What else? Concavity and points of inflection. Now, when I had the graph, how did I determine concavity? If the derivative was increasing or decreasing. But I can't do that just by having the function of the derivative. Okay? So what's the other way I can determine concavity? If you remember that chart we drew up there, what's the other way I can determine concavity besides the fact that f prime is increasing or decreasing? Say it again. What about the second derivative? Positive or negative? Who said that? Good. Okay. So I want to go to the second derivative and I want to do a sine line with the second derivative, and that's going to tell me points of inflection and concavity. So second derivative is going to be 24x minus 12x squared. All right, then what do I want to do to it? As I do what else as well? Set it equal to 0. So I'm going to set it equal to 0. I'm going to factor out a 12x. And that leaves me with that. So my two x values are 0 and 2. All right, what do I want to do now? Sine line. Okay, anytime you take the derivative, set it equal to 0, you always follow it up with a sine line. Anytime you take the second derivative, set it equal to 0, you always follow it up with a sine line. All right, so 0 and 2. All right, number on the left?
-1.
-1. So if I plug in -1 to the first piece, that piece is... If I plug -1 in the first piece, that piece is negative. I plug -1 in the second piece, that piece is... So a negative piece and a positive piece produces a negative. Between 0 and 2? 1. I plug in 1 to the first piece, positive. Plug in 1 to the second piece, positive times positive, positive. Number over here? 3. Plug it into the first piece, plug it in the second piece, negative, positive, and a negative gives me a negative. All right, so Xavier, what does that sign line tell me? Give me something that sign line tells me.
That it's concave down.
What's concave down?
The graph
Of
F
F.
is concave down,
So F is CCD on
negative infinity to 0.
negative infinity to 0 and
2 to infinity.
2 to infinity. Because,
F double prime is negative.
perfect. All right. Michaela, what else does it tell me? If I'm concave down when I'm negative, I have to be
Concave up and positive.
when I'm positive. So when am I concave up? What two numbers is the positive between?
0 and 2.
0 and 2. And what's my reasoning why? Because F double prime is? F double prime is
Positive.
positive. Good. Okay, Ariel, what else does this sign line tell me? What else can I get?
The points of
Points of inflection. So F has POIs at
0,
and
2.
because
F double prime changes from negative to positive.
all right, this is one where we don't have to be too specific. We can just say F double prime does what?
Changes sign.
Changes sign. There it is.
F double prime.
Thank you. Because F double prime changes sign. All right, so let's verify that by looking at our graph. So here's our graph. Okay, so we said F was concave down from where to where?
Negative prime to 0.
Negative infinity to 0. So negative infinity to 0, would you agree that this piece right here is concave down? Yes. Then from 0 to 2, it says it's concave up. So from 0 to 2, it's tough to tell right here, but from 0 to that point right there, would you agree that that's concave up? Yes. And then from 2 to infinity, it says we're concave down. So from 2 to infinity, would you agree that's concave down? Yes, because we said concave down like a
Brown.
Brown, not a clown. And concave up like a cup. All right. So that's a lot of information we got right there. Okay, so let's recap what we did. Gavin, what was the first thing we did? Found the derivative, then what we do with it? We set it equal to 0, and we found those values. Alexis, once we had those values, those x values, what do we do with it?
We create a sign.
We created a sign line. Okay? Okay, then Trevor, how do I evaluate my sign line? What was I looking for?
You take numbers before the interval.
Right, but once I determine what's positive and what's negative, what can I then?
You can see where the relative mins and maxes are.
Relative mins and maxes are good. Relative extrema. What else can I determine?
I missed that part.
Where f is increasing or decreasing. Okay, so I can do all that from the first derivative.
And
What? Yeah, critical points. I go to the second derivative. What things can I find from the second derivative? POIs and interval of concavities. All right, go to your module for today. Pull out the 12-6 practice problems. Get with a partner if you want to get with a partner. Work that first problem. And then come back to me. All right, let's knock this out. Need to start by taking the derivative. I think, again, what's causing us the problems? That always causes us the problems. That's not calculus. The stinking algebra is what's killing y'all. All right, at this point, we want to set it equal to 0. And we want our squared term to be positive. So if our squared term is negative, then I need to factor a negative out so that my squared term becomes positive. What else can I factor out besides the negative? I can factor out a -6. So that means this becomes x squared, which I'm going to move to the front. This becomes positive x, and this becomes -2. So let me stop there and make sure we're good on that. Questions on what I did there? Okay, because that right there is usually why people struggle with this problem. Now, here's the deal. This -6 has to stay. You cannot get rid of it. Why does it have to stay?
To find the sign.
To find the signs, because if I get rid of that, then all my signs are opposite of what they should be. The -6 has to stay. Okay? So what x values do I get from it? What do I get from this? -2. What do I get from that? I get 1. Okay? So over here, -3 is good. So this piece is always going to be negative. This piece is always going to be negative. I plug a -3 in there. This piece is going to be negative. Plug a negative in there. That piece is going to be negative. 3 negatives give me a negative. I plug in 0. This piece is still negative. This piece is now positive. This piece is negative. So a negative, positive, and a negative gives me a positive. Over here, 2. This piece right here, still negative. This piece, positive. This piece, positive. A negative, a positive, and a positive give me a negative. So I now have my sign line, which means I can now do 2 things once I have my sign line for the first derivative. Jessica, what 2 things can I do once I have my sign line for the first derivative?
you can find the relative max and minimum.
And what else can I do?
You can find where it's increasing and decreasing.
All right, perfect. So I have a relative max where? Where's my relative max? 1, because
F prime changes from positive to negative.
what does?
F prime.
F prime changes from positive to negative. All right, then I've got, Vishali, I've got a relative min where?
At x equals -2,
Because
f prime changes from negative to positive.
Okay. Then Deborah, I can say between negative infinity and negative 2 and 1 and infinity, my f is doing what?
It is decreasing.
Because
It's negative.
what's negative?
F prime.
F prime. So since f prime is negative here and here, we're decreasing on those intervals. Gavin, what's going on between negative 2 and 1?
Increasing.
What is?
F.
F is increasing because f prime is positive. All right, let's get to the second derivative. So I get to the second derivative. So that's going to give me negative 6 minus 12x. I set that equal to 0. I solve. And I get x equals negative 1/2. Xavier, what do I do with x equals negative 1/2?
Put it on the sign line.
Put it on the sign line. Good. So I put it on the sign line. All right. On the left, good number on the left. Excuse me. Negative 1. So if I plug negative 1 into that, positive or negative? Positive. Xavier, a good number on the right would be
0.
0. If I plug 0 in, I get
Negative.
negative. All right. So Jordan, I can get, that sign line tells me two different things. Tell me one of them.
I did all this wrong.
That's fine. But you can tell me what that tells me, regardless of whether or not you did it all wrong.
Okay, I'm confused right now. I really can't tell you right now.
What are you confused about?
I don't know what's happening right now.
You gotta give me a point where I can pick you up.
I literally, this whole thing, I did all of it wrong, so I just don't know where
Well, I don't care about what you did. I want you with us now. I want to know where I can pick you up. Where can I connect with you and then help you out from there?
I don't know.
Can't give me anything?
No.
All right, Wilson. This tells me, the sign line for the second derivative tells me two different things. Give me one of them.
It's the one places where it's concave up and concave down.
Concave up and concave down. So when is it concave up?
When f double prime is positive,
Okay, so where's that going to be?
the to the left of negative 1/2,
Right, so what's my leftmost number if I'm writing it in interval notation?
negative infinity.
Negative infinity to
Negative.
negative 1/2. So we're concave up there because f double prime is positive. And then from negative 1/2 to infinity, we are,
Concave down.
because
F double prime is negative.
f double prime is negative. Very good. Okay, Michaela, what's the other thing that the second derivative sign line tells me besides p capital? Point of inflection. Do I have a point of inflection? Why? Where is it and why? You said it.
Prime.
Nope. What's this the sign line for? F double prime changes sign. Good. All right. So let's do a quick. I want everybody's eyes on me. I want you to stop what you're doing, and I want your eyes on me. Okay, and let's recap what we can do with the function now. Okay, Deborah, what's the first thing we do with our function if I'm wanting to learn everything I can about it?
You find the derivative.
Find the derivative. After I find the derivative,
You want to find the maximum.
all right, you're doing too much. I just want piece by piece. After I find the derivative,
You say equals
set it equal to 0. Factor it and get my x values. Once I get to my x values, do the sign line. What does the sign line of the first derivative tell me?
It tells you if it's increasing or decreasing.
All right, quit saying it. You guys
Oh,
quit
okay.
saying it.
Tells you if the function is increasing or
If f is increasing or decreasing, and it tells me
the relative extreme.
relative extrema of f. Perfect. All right, Trevor, I'm done with the first derivative. I'm moving on to the
Second derivative.
second derivative. What do I start doing with the second derivative?
Well, you find the second derivative, and then you set it equal to 0.
All right, stop. Next,
Solve for x.
solve for x.
Sine line.
Sine line. What does my sine line of the second derivative tell
Sine
me?
line will tell you if you're concave up or concave down and twisting flexion. Perfect.
All right, you do not have to work that assignment. We'll do a couple more notes on Monday, and we'll work that assignment that you've started. Okay? All right, have a good weekend.